final question on this paper now. So the temperature of a mug of coffee at time t can be modelled by the equation T of t is equal to TR add 90 minus TR e to the minus 20th t, where TT is the temperature in degrees centigrade of the coffee at time t minutes after the coffee was poured into the mug, and TR is the room temperature in degrees centigrade. So the first part says, using the equation for this model, explain why the initial temperature of the coffee is independent from the initial room temperature. Now, the key thing we've got here is the word initial in both. Now, the word initial means at the time when t is equal to 0. Okay, so no minutes have passed at the initial temperature. So if we put t equal to 0 into this, we get t of r add 90 minus t r e to the minus a 20th of 0. So at minus a 20th times 0 is 0. And so we've got TR add 90 minus TR e to the 0. And we should know that anything to the power of 0 is 1. So we're left with T of t is equal to TR add 90 minus TR. So T of t is equal to 90. So what we can say is the fact that the TR values cancel each other out. Meaning that the initial temperature is independent. Part B, calculate the temperature of the coffee after 10 minutes if the room temperature is 20 degrees centigrade. So what we've got is we've got T is equal to, well, T of t, sorry, not T of t, T 20 is equal to 20 add 90 minus 20 e to the minus a 20th of 10. Subbing our values in for 10 minutes and 20 degrees. So this is T is equal to 20 add 70 e to the minus a half, and just putting that into our calculators gives us T is equal to 62.5 degrees centigrade, and that's our final answer.